Friends, this is lecture number 54 of irrigation and drainage course. In this course, we are going to learn the economics of drainage project. So basically, once we are looking for investing the money in drainage project, so basically we would like to know how much, whether it is beneficial if you put money on this drainage project like 5 years or 10 years or 30 years down the line. So basically this is very important because this involves a lot of costs, right, like investment in constructing the drainage channels and laying out the tiles. So all those things, there is a lot of investment involved. So if you put investment, okay, so whether this is worth to invest this particular money in drainage project, so that you will attain the desired benefits in 20 years or 30 years down the line. Okay, so here what we are going to see, we are going to learn different terminologies initially, then followed by discounting cash flow method, and then different financial or the economics indicators to understand whether the investment we are keeping or we are putting in drainage project is really beneficial or not. Okay, so then here the objective of the land drainage basically to bring land into production. So that's number one. So whatever the land which is under inundated or the waterlogged condition, so the number one objective is to bring that particular land into production, and the second is to increase the productivity of existing cultivable land. So the productivity, that means the yield divided by amount of water we are giving to the plant. So that productivity needs to be increased, and second is to evaluate the benefits and costs of any project scheme, or in this here the drainage project. So these three objectives basically we look into in drainage projects. Okay. So then next is so the cost of drainage project. So cost involves, like for example, initial or capital investments. So this is basically to canals, right, and control works, ditches, pipes, pumps, land leveling, land clearing, farm roads, relocation of existing structures, so etc. So these things required initial investment. So that we can categorize as a cost, and then there are some replacement investments. This is also has cost. For example, loss of existing property. Suppose your drainage project is going on, and all of a sudden some natural calamity happened and you lost some of the properties. And the other one is recurring costs of maintenance works. So every year you have to put some cost on maintenance, and recurring costs of operation and management of the scheme, and other associated costs such as some kind of remolding, all other things. So, okay. So this is basically, so the two categories of costs. The first one is investment, like the initial cost, and second one is the maintenance cost. Okay. So basically the two broad categories. Then so next is what are the benefits. So the benefits here, the classification. So it's like a tangible benefits. So tangible benefits are directly you can see the benefits like enhanced agricultural production, like increasing the yield. That means the right now the land is arable. So before it was not good for agricultural production. Now because of the drainage you will be able to grow the crops. So that's why the agricultural production is going to enhance, and water supply for domestic and industrial use, etc. So whatever the outflow you are getting from the drainage, so that can be treated and used as water supply for domestic, and also for industries. So, this is a directly or direct benefits from agriculture, drainage. So, then other one is a intangible benefits, like the indirect benefits. You can see the improvement in local environment because of the water, the impound water or the ponded water is being, the excess water is being taken out. So, the environment will be clean, right. So, that really improves the local environment and improved hygiene and better trafficability, because now the soil is like aerated and it will be more suitable for trafficking and etc. So, these benefits are categorized basically two classes. One is tangible benefits and intangible benefits. And then the computation of cost and benefits, this is very important. So, once the project is done, so finally we are going to see the cost benefit ratio. So, that is if that is more than 1, then the investment you are putting in the particular drainage project definitely will be worth. Okay, so, here the computation of cost and benefits, the cost and benefits occur at different times during the project period. The whole project period we are going to classify into 3 time periods. So, one is economic life, actual life, terminal life. So, something like that. We are going to discuss those. And the costs, project construction. Okay, so, and then benefits are like a project maturity. So, generally the costs are happen during initial stages like project construction, and benefits once the project gets maturity, then you get the benefits. And then discounting is a device to bring cost and benefits occurring at different point of time onto a common base. So, since the costs and benefits are happening in 2 different time periods or different time periods. So, in order to understand the investment you put now, whether really it is useful, really it is worth to invest in the particular project or will be able to get the benefits after 20 years. So, what happened, the benefits and costs, there are the different time periods. So, in cost benefit analysis, what we do, so benefits and the costs will bring the both on the same base, and we will compare whether it's whether we get profits or not. So, for that this discounting cash flow analysis is very important. So, discounting will be a device used to bring the cost and benefits on the or of the different timelines and to bring to the same timeline, compare those things. Okay. So, then next is the time periods of the drainage project. If you see the project life on x axis in years and terminal value on y axis. So, here the actual life. So, actual life generally 50 to 100 years for drainage project. So, well maintained pipe drainage will have up to 50 to 100 years of age. So, that is the actual life. So, generally at actual life you do not get any terminal value. So, terminal value will be 0. The project terminal value would 0, but you can the project can continue. So, okay. Then the next timeline, the life is economic life. So, this is economic life. So, corresponding to notional lifetime at the end of which project will get renewed. So, economic life, what happens? So, the once you take at the end of economic life, the project cost is 0 terminal value. If you see our minimum or 0 terminal value can be achieved at the end of economic life. So, beyond that the value of the particular project will be 0. For example, you buy a car, right. So, initially the life will be more in after initial first year. If you the resale value will be more than during the course of time or after usage, like 5-10 years, the resale value will be less, but after some time, after 10-15 years, if you see, so this will be still have a 0 value, but you can still use it. Okay. So, that is economic life. So, economically it is a 0 value, right. So, that is the project. Then the next is Okay, so the next is the financial life. So, in the financial life generally they often imposed by lending agency. So, if you are taking loan from a financial company, so they decide like 10 years or 15 years of time. So, that is the financial life, and the repayment period of the loan taken from a lending agency. So, this is basically the repayment period. 10 years very much shorter than EL and AL, like economic life and actual life. So, this is 10 years basically. So, the project has terminal value at the end of the financial life. So, even at the end of the financial life, so it has some terminal value. Okay. So, farmer expects benefits equal or profit preferably exceed the costing arising during the financial life. So, still farmer expects the benefits equal or exceeding what he was planning during the financial life. So, these three lives are very important in during the economic analysis of a drainage project. So, the next is as I said, the discounting cash flow method. So, this is very useful in order to understand the investment you investment you made today, definitely whether it is really worth in 10 years or not. So, what happened, the benefits will be bring back to the present value, right, the benefits which is happening in 10 years. So, that value will be taken back to the present value and compare the cost and benefits. So, that in discounting cash flow method we are going to see that. The sum of money observed now is worth more than the same sum money in 10 years. So, this is what we test in case of discounting and cash flow method. For example, here the present value of an asset is 100 rupee, right, and interest rate is 10% and value after 1 year would be 110 rupees. So, this is simple math, like PNR by 100 if you substitute. Look, 100 rupee and 10% interest rate and 1 year. So, you after 1 year you get 10 rupee extra. So, 110 rupee. So, the discounting factor would be 100 divided by 110, that is a 0.909 is the discounting factor. So, that means, if you are expecting 110 rupee in next year, the 1 year, if you are expecting 110 rupee in a year, so how much you need to invest. Okay. So, that is 110 multiplied by the discounting factor, that is 0.909. So, that will be 100 rupees. So, that means, so the benefits 110 you bring to the original value 100 rupee. Okay. And the discounting is the inverse changing compound interest. So, this is the equation we will be using it for estimating the discounting factor. So, that is every year, this is yearly. So, I equal to 1 to PL, PL is the project life, 1 by 1 plus rate of interest power I is the number of years. Okay. So, in this way this is the discounting factor, and there is a table available for this calculating the discounting factor. If you know the number of years and then number of years and then percentage rate of interest on x and y axis, then you get the particular the DF. Okay. So, that we are going to see that. Oh, here. So, this is a table. For example, what is the present value, right? What is the present value if the drainage project expects a benefit of 10,000 rupees per hectare after 20 years at an interest of 10%. Okay. So, you are expecting 10,000 rupees per hectare in 20 years, and if you are investing in this particular project at a rate of 10%. So, what would be the present value of this? So, for that this is the discounting table. So, this is a 10% and at 20 years 10% 20 years. So, you got like discounting factor, that is a 0.14864, and if you can multiply with 10,000 you get 1490. So, the present value of 10,000 hectares is 10,000 rupees per hectare is 1490 rupees per hectare. Okay. So, if you can invest 14,990 rupee per hectare now, like at a 10% interest rate for 20 years, you may you expect 10,000 rupee per hectare from the project. Okay. And then computation of annual repayment. So, once you decided, so this much you have to invest, right. So, then you may have to take loan. Sometimes if you do not have money, you may have to take a loan. So, once you are taking loan, so how to estimate the annual repayment. So, here the annual repayment on initial loan at a rate of interest and over a repayment period. So, here initial loan amount, rate of interest and repayment period. So, these three parameters are required. So, F is the annual repayment is equal to, so IC, so that is IC is the initial investment. So, that is the initial loan, and then PWF. So, that is present worth factor. So, present worth factor again calculated by 1 plus the rate of interest, right, and the repayment period minus 1 divided by rate of interest 1 plus rate of interest power repayment period. Okay. So, these two equations, using these two equations you will be able to find out the what is the repayment annual repayment amount for a particular loan amount. Okay. And then third is the inflation factor computation. So, inflation that means, so the amount of a particular object will definitely will increase in in a future years. Okay. So, there is a particular factor. So, that is called inflation factor. So, the future costs and benefits are increased in value to take account of an assumed rate of inflation, right. So, yearly inflation factor, so that is 1 plus interest rate power project life. So, this is inflation factor which is computed with an equation 1 plus IR, that is interest rate, and then project life. Okay. And this is also, there is a table available for inflation factor. You can find out the inflation factor from the table. So, then there are financial economic indicators, so through which we can decide whether the investment is really beneficial or not. So, one is the net present value, NPV we called. So, NPV is the difference between the present value of benefit and cost. Okay, the present value of the difference between the benefit and cost. Okay. And it is also known as net present worth, NPW, and clearly a positive value of net positive worth or net present worth or net positive value. So, which is described with an equation which is equal to benefit minus cost divided by 1 plus RI, that is rate of interest power I. Okay, this is, so every year we are going to find out what is cost benefit difference, right, and then the corresponding 1 plus RI power I. So, then that will be the net present value. Okay. So, the net present value generally it needs to be a positive value, because the benefits should be more than the cost, and the indicator here is the NPV should be, so NPV should be positive. Okay. That is one thing. And then so the next is benefit and cost ratio. So, benefit and cost ratio is the present value of benefits divided by the present value of the costs, right, that is the ratio. So, for a project to be economically viable, the benefit cost ratio should be more than 1. Okay. So, because benefit is always more than cost in case of profits. So, BC ratio is estimated by every year anyway. So, this is the benefit divided by 1 plus R I power I and cost divided by 1 plus R I power I. Okay. This is BC ratio. So, now let us see an example here, the cost evaluation of a drainage project. So, a farmer in India plans to drain an area rough grazing land to enable it to be used as a arable land. So, there is a waste land, so I mean grazing land, basically the grass land. So, he wants to turn that into a agricultural land. So, drainage system here he planned for a pipe drainage with molding, construction cost, that is 52,000 per hectare, and remolding every 7 years, right. So, that is 2,000 per hectare he invests, and maintenance every 5 years 1,500 per hectare. So, these are the the costs, and he went for financing, right. So, the bank loan of 10 years at 10% interest rate and inflation 5% over the life of the drainage project. Okay. So, the benefits what he is expecting is the expected additional profit on arable land is 9,000 rupee per hectare. So, that is what he was expecting, 9,000 rupee per hectare. So, let us see, let us evaluate the cost and benefits of this particular project and whether his investment is beneficial or not. Okay, calculations here if you see. So, the annual repayment period on initial loan. So, this is what he got a loan from a bank or financial company at 10% interest rate and over 10 years, okay, 10 years period. So, this is around 8,460 per hectare. Okay. So, this is from the formula capital F is equal to IC by PWF, present worth factor. So, the present worth factor has a formula. So, knowing the values, annual repayment, so and this is the initial investment, repayment period and rate of interest. So, putting those values you get the annual repayment will be 8,460 per hectare every year. Okay. So, the future cost of molding and maintenance. So, I am going to show you the table because the all analysis was done in Excel file. So, let us see the column by column. So, here the first column will be like if you see here, this is the first column, sorry. So, the first column initial loan amount every year 8,460. So, that is what here 8,460 per hectare, column number 1, that is the annual repayment. Okay. So, he has to repay all these things, and then this the third column if you see the maintenance, oh sorry, this is the second column, the loan amount is, this is the column number 2. Okay. So, this is the column number 2, and then the next is the column number here if you see the second point. So, that is the future cost of molding and maintenance, that is a column number sorry. So, the column number 3. So, every 5 years, right, every 7 years remolding, every 5 years the maintenance, right, maintenance 1,500 rupees. So, like that. So, again after 10 years it is maintenance, 15 years maintenance, 20 years maintenance. So, remolding 7 years, 14 year and 20 year. Okay. So, that is the thing. So, that is the column number 3, and then column number 4, that is the benefits. So, column number 4 and benefits are increased by standard factor to make account inflation rate by 5. So, we are going to so column number 4 is sorry. Yeah, column number 4, this is the benefits. So, that is what he initially is expecting these benefits, right. So, this is the benefits. So, that is in sorry. Okay. Yeah, so that is in column number 4 benefits. So, maintenance mold may column number 3, benefits column number 4, and inflation factor, that is 5%. So, for 5% there is a table, this is the inflation factor table. So, if you see the 5%, right, it is the mark, see 5% mark, and then up to 50 years it is given, we will take up to 20 years. So, this whole column will be taken out from here and inserted in here. Okay. This is all 1.05, 1.1, this is from 5% and up to 20 years. Okay. So, that is column number 5, and now this is actual future cost and benefits of 5% inflation. So, we are going to, with this inflation rate, we are going to translate all these values, right, except the initial loan amount. So, loan amount will be same, that is in column number 6, and molding and maintenance. So, that is column number 7, which will be equal to the column number 3 mold maintenance and the inflation multiplied by inflation factor. So, that is column number 7, and benefits. So, the benefits also needs to be inflated. So, that again 4 multiplied by the inflation factor. So, that is benefits column number 8. Okay. So, now benefits minus cost. So, the benefits here. So, the benefits here, and the cost. So, cost in the sense the loan amount and molding and maintenance. Okay. So, these so benefits minus cost is sum of 6 plus 7 and benefits. So, this is a cost minus benefits minus cost. So, this column. Okay. Now, so this is actual future cost. So, what we have to do in discounting cash flow analysis. Now, we have to bring this future benefits into the present value. So, that I mean, if you see from here to here, so we are going to bring the future value to present value. Okay. So, let us see the discount. For this, what we need a discounting factor. So, discounting factor, there is a table for 10%. So, for 10% interest rate for 20 years, you will have the table values like this. Let me see whether I have the table or not here, but previously I was showing you like here. Sorry, this one. So, this table. Okay. So, from this table 10% and 20%. So, the whole column will be taken and incorporated in column number 10. Okay. So, with the discounting factor, now we can bring back to the present value. Here benefits minus cost, that means the column number 11. Column number 11 will be equal to discounting factor multiplied by benefits minus cost. Okay. So, this one. So, this is the present value. Now, NPV, net present value. So, this will be every year you need to. So, this is a sigma. So, that means every year you need to accumulate, I mean sum up. So, this is initial, right, 900. Now, 900 plus this one will give this, and 2096 plus 1485 you get this, right, and this plus this you get this. Okay. So, like that this will be summed up. Okay. So, now the NPV is the present value of the future benefits, cost minus benefits. Okay. Future benefits. Now, if you observe this, all are positive, the first thing. So, NPV is a positive. Okay. That means it is worth to invest. And then let us focus on year number 6, and let us discuss the results here. Let us go to the next. This is inflation factor, and economic evaluation. If you see the third point, the second point, there is present values, future values. Okay. So, third point, whatever we discussed over there, the procedure to evaluate cost benefits to any 1 year is explained in the year number 6. For example, the annual repayment is 8,460. The benefit of 9,000 per hectare, this is column number 4. Obtained at the outset has increased in value due to inflation. Okay. So, that is column number 8. So, and then excess of benefit over cost, that is 3,600, column number 9 has present value. So, that is this is the present value. Okay. So, so if you observe this, so the present value here, right. So, the same thing, if you see the column number 9, which is cost minus benefit, benefit minus cost. So, that is the present value. So, the terminal value of the project at the end of 20 years period considered to judge as 20% of its initial cost, that is 0.2 times 5200, that is 10,400. If you see, let us see in the table. So, the terminal value here. So, this is the terminal value. So, at the end of 20 years, benefits. So, benefits will be 20% of the investment, 20% of investment, and then benefits minus cost, because you only expect benefits and no cost, that will be 0 cost. So, still benefits minus cost will be same. Now, discounting terminology value, so use a 0.15, you get 1560 for this amount, right, benefits minus cost. I mean, this is the present value now. So, now now this plus this will be this one 58,190. So, that way you can also have terminal values. Okay. Now, let us go back to the calculations. So, the this is the computation of for 6 years 10%, and if you can, this is what 0.56 something like that. That is what, if you see here 0.56 multiplied by 0.56 we did 0.56 into 3,600, the corresponding, I mean 6 years benefits. Okay. Sorry. Okay, so now discussion. So, NPV is 14,810 per hectare at the end of 10 years financial period, and 56,630 per hectare at the end of the considered 20 years economic lifetime period. So, you can, if you can ignore the terminal value, the present value of all cost PVC arising over the first 10 years. So, that is cost in column number 6 plus column number 7 into discounting factor. So, that will be this much. So, this is what the present value of the cost, and similarly the present value of the cost after 20 years you get 57,911.6, and the benefits by cost ratio after 10 years, right. So, benefits minus cost, this is we have column number 11, and cost, that is the column number we have cumulative PVC, right, the last column divided by cumulative PVC. So, from the table you get column number 11 for 10 years period, that is 14,794.95 plus cumulative PVC. So, that is 55,526.55 divided by the same, you get 1.27 for 10 years. The cost benefit ratio will be 1.27 for 10 years period. Similarly, for 20 years period, you can also estimate cost benefit ratio. So, that will be like 2.0. So, from these indicators it appears that the project is financially viable in the short as well as in the long term. Okay. So, because the NPV, that is net positive value, is positive, as well as the benefit cost ratio also the positive. So, that is why this is I mean worth to keep, I mean worth to put amount or invest in this particular project, so that you will achieve the desired benefits. Okay. So, there is a thumb rule that if you are estimated like even $1, like $1 benefit, right, in over a period of time, then definitely you need to invest in the particular project. Okay. So, this is all about the economic evaluation of a drainage project. So, basically there are few terminologies we observed in this. What is like project period? So, basically it has a financial life, economical life, and then actual life. So, all these, I mean the project has these 3 lives, and the next is the discounting analysis, discounting cash flow analysis will be done to bring the benefits which are in the long run. So, that to be bring into the present value and compare with the cost, and will be see whether we will be seeing whether there is a benefit or not, right. So, that is the one thing. and we solved a problem on cash flow discounting analysis. Okay, so drainage project problem. So, and thank you so much. In the next lecture, we are going to talk about some problems. That's a tutorial, right? Thank you.